In this video, we're going to look at associative forecasting. So, up to this point, we've been discussing time series models, where we only look at the sales data and try to understand the pattern in sales data, trend, seasonality, stuff like that. But in associative forecasting, we try to find an association between some predictor variables and sales. So like, for example, the price we charge and demand, or price and advertising expenses, and so on. So we'll use regression analysis technique to find that relationship between sales as the Y value and some predictor variables like price and advertising expenses X. First, we'll start with just one X. This is called simple linear regression. So we start with an equation like this: Y hat is A plus B times X, where A is the intercept, B is the slope, and X is the independent variable. X is not time like in the trend projection. This is actual independent variable. So let's look at an example. Suppose we have sales recorded in millions and the area payroll is in billions. So the units are very, very important. You have to pay attention to that. And we have 6 data points. Okay. So we are now trying to fit a straight line through these points such that the sum of squared deviation is minimum. That's least squared estimate. So you use the same formula like before and find the slope and y-intercept, and that is your formula. Then you plug in the payroll and you get an estimate for sales. Payroll should go in billions of dollars, and sales estimate will be in millions of dollars. So here is how it is used. So you have next year payroll is estimated to be 6 billion, so you put 6 in there and you get 3.25 as sales, and that is in millions, so that is $3,250,000. Now that is only a point estimate. Actually there will be some statistical error at that point, so there will be a margin of error for our estimate, and so we need to find a standard error for the estimate, and the standard error for the estimate is given by this formula. It's kind of hard to compute this formula, but there is an easier formula, which is this one. So we'll use this formula to compute standard error of estimate. Okay, here is the example. Okay, we can even construct a confidence interval, but we won't get into that in this class. Now, correlation is an important concept that we want to study when we are talking about an independent variable and sales, okay, like price and sales, or demand, or advertising expense and sales. So a correlation between two variables is defined as the strength and direction of association between two variables. So if you have positive relation, you will have positive correlation. If you have negative relation, you will have negative correlation. And how strong the correlation is given by the number. Okay, if it is -1 or +1, that means there is perfect correlation. A number that is closer to 0 means the correlation is very weak or non-existent. So the closer R is to either the +1 side or the -1 side, the strength of the relationship is strong. And here is the formula that we will use to find correlation coefficient. Here is what I was just talking about. So this is negatively correlated perfect correlation. Okay, and then this is strong correlation but not perfect. Now here it is close to 0, so that means the correlation is non-existent or very weak. This is strong correlation on the positive side, and then there is perfect correlation on the positive side. So here is the worked out example. We'll work out an example in the next video. And when you take that correlation and square it, what you get is called coefficient of determination. And the coefficient of determination is a value between 0 and 1. And closer to 1, the better the fit is. The the line represents the actual values much better if r squared is closer to 1. Now we can extend this to multiple regression analysis when we have more than one x variable. So it will be a plus b sub 1 x sub 1, so one slope coefficient and a second slope coefficient and the second x value. We are not going to go into the computation of this. We will simply use a multiple regression equation like this to find forecasts.